The set notations here. Let's break this apart. So before I answer the question, Will, before we answer the question, we're going to break up a couple of notations because these notations, you're going to have to learn to use them. So, when you use a capital letter, okay, in year 7, we use a capital letter to denote something. What does it mean when you use a capital letter on its own? So the capital A, anyone know? It's a set. Now what was a set? Again, what's the definition of a set? Will, do you remember what a set is? You don't. Felix?
Is it like it's like a group?
Yeah, that's it. Just exactly what you just said. It's just a group of things. Okay, so write that down if you didn't know. Set just means... No, it can be anything. It could be, yeah. And so back in probability, when you first learnt it in year 7, it just is a group of things. When you use a capital letter, it just means I've got a group. So I could say this is group A. Technically, you guys are maths methods B or A or whatever it is. You are in a group. We call that a set. Okay? So you can have set A, which means group A. Group B. It doesn't have to be numbers. It could be letters. It could be items. It could be colors. It could be anything that you want. We're just saying it's a group. Okay? Phone's off. Yeah. So set A just means group A. In group A, Group A, I've got 1, 2, 3, and 7. Group B, I have 3, 4, 5, 6, and 7. Now, just before we note, so this is Group A equals 2. So what do I have in Group A? Now, anyone know the name of the curly brackets, besides calling it curly brackets? These are called curly brackets. Also, what else? What's the proper name for them? Not inclusive. So curly looks like this. It looks like that. What are those called again? Called curly brackets or, starting with B? No, B. B. Yeah, I know. Braces.
What kind of bracket?
It's curly bracket. Curly bracket. So you got a curved bracket, you got a square bracket, and you got a curly bracket.
Like Mr. Kylie.
Okay? 3 different brackets there.
Yeah, forward. Yeah, forward.
Now, 11. Focusing. Thank you. The reason why I'm asking is because for each bracket, the 3 that I've just drawn there, they're used for different occasions. You've got your open bracket, closed bracket, and curly brackets. Curly brackets are specific. It's only when you want to identify what you have. So you don't use close or open. You only use close and open for when you're talking about the interval. So you're talking about between A to B.
Is that called a closed bracket?
Yeah. The middle one's closed. This is called open bracket. The curly bracket is only used when you list things. So if I want to list the names of the students in my class, I'll be using a curly bracket or braces. Okay, the braces are used to identify. So you can see I'm identifying 1, comma, 2, comma, 3, comma. It could be 1, comma, black, comma, white, comma, chair, comma. It could have been that. It doesn't matter. But braces are only ever used to identify a list. Okay, you don't use it to identify other things. So one of the common notations you get in year 12 will be something like this. You'll get X element of R except for, and then you use the curly brackets where you say 1. Yeah, I know. But that's, eventually I'm going to get you to learn what all this means. And that's the goal. By the end of today's session, your goal is to be able to read what this means. Okay? Which I'll get there. But what I'm breaking up right now is curly brackets you only use when you're identifying or listing items. Okay? Now, so this one just says, group A, I have this list. My list of numbers are 1, 2, 3, and 7, separated by commas. Okay, if you don't put a comma, then it just means it's one number. So if I didn't put a comma between 1 and 2, it's considered as 12. Okay? Same thing with B, that's just saying group B has, and I'm listing, so curly brackets 3, 4, 5, 6, 7. Okay? What's this symbol mean again? You learnt this in year 7. Anyone remember the name? Hands up.
Intersection.
Intersection. What does intersection mean, Ian? Not outside? Yes, if it is 2 circles, but I don't have 2 circles right now. Wait. Shh. Listening. We have intersection now. Yasmin, what does intersection mean? Good. It doesn't have to be numbers. It's what they both have in common. What is in list A and what is in list B that they both have? Okay, so both in common. So this means... Okay, so that's what... no, the list. So list A, what's in list A that is in common with list B? Okay, next one. No, we're talking about a list, so items. Wait. Write down. Need you to focus, Ryan.
So, but if they had like just commas in it, would that be the list?
No, but we just said commas are used to describe.
What if it's just cat? Yeah,
if you wanted to use commas, then it would have been comma, 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 exclamation mark, question mark. And it'll look like that. Okay? Yeah. All right, there we go. Now, next symbol that I wanted to talk about is that U-looking shape. What is that one called again? Yes, Felix? Union. Now, union, what does union mean again?
All of them together.
All of them together. It's when you group them. It's sort of like group A, if we have... Well, if we have group A is my class, Mr. Tran's class, and I union that with, I don't know, the next class over there, then what we're doing is we're taking every item or students in this class and we're including it with the other class. That's what union means.
Do you have to repeat numbers? So if you have 2 3s, you write.
Very good question. So, this is one of the common questions that comes up. When you're unioning, do you repeat the numbers? So let's say Ryan, if this is my class and I put Ryan and we merged our class with that class over there, I don't have 2 Ryans, I don't have 1 Ryan. So Ryan is himself. That's one A.
What if there's another Ryan over
That's
there?
One I. But you, I'm talking about
What
you.
if I'm clone?
Well, that's a different story, isn't it? If there's another.
Like, because there's 2 3s there, when you put them in union, you only put 1.
But that's what I'm trying to describe. When we say union, we're just saying if you are unique, if you are just one number, and I put you into that class, you are still that number. You don't duplicate into 2. So if I take you right now and I chuck
What if there's already another number like me in that class?
But then that's a different number.
But maybe they're both 3s.
All right. I don't know if you're playing with me right now, but
I think he just means, so you know how there's 2 3s?
yeah, I'm guessing, just in case Ryan's not playing with me, what his question is, if in this room I have a 3 already, and then in this room I also have a 3, if I put them together, okay, if they say, listening, if they do say, okay, if they do say that this is a different type of 3, so meaning this is a 3, yeah, or a little 3 with a little 1 underneath, if they say that each one is a different group, then yes, you would include 3 and 3, but you have to realize that there are 2 3s there. But if they're just talking about unioning as like numbers, the numbers that I only have is only 1 3, then you don't repeat that 3 because it's unique. It's like Ryan. Ryan could be doing 2 subjects. He could be in a German class and he could be in a methods class, but just because Ryan's in both classes, you don't count Ryan twice. There's only 1 Ryan. Okay?
Well, so they're the same number.
That's only if that's what the question's saying. That's only if the question says that.
Yeah, no, that's what I did.
Okay? So normally we don't double it up. Normally we don't double up unless they tell you that those are 2 unique numbers.
Like it was 3 and a 3 with a dash on top.
Or they just tell you in the question. Yeah? Okay, so union means together. All right. Quiet down. Now, example 1A, let's answer the question now. So it says A intersection B, which means what is in list A that is in common with list B?
Maybe you should draw the...
Wait. Now, when you're answering this question, I know the answer is 3 because they both have 3 and they both have a 7. Yes, they do. But the way you answer the question, you have to answer it in a list as well. You're saying in group A intersection B, curly brackets. Will, I want you to be writing this down, not talking. Yeah? We're using curly brackets and we're saying it's with 3, 7. Okay?
Do you have a pencil?
I do. Ryan, where's your pen?
I had it on the way here, but I think I fell out. It was in there.
Next one, B. When you're writing your answers, like I said, I want you to learn to use notation. So we're saying, Sydney, don't talk while I'm speaking. A intersection B, which means that's my group. In my group, I have this list. I'm using braces to say that what list I have a 3 and a 7. So when you're answering the next question, A union B,
Everything together.
yeah, everything together. But in this case here, because these are the set of numbers I have, 1, 2, 3, 7, these aren't different. They're the same number, so you don't repeat the 3s. Okay? Yes, exactly. So here, what you should be saying is you got A union B, 1, 2, 3, 4, 5, 6, 7. But you don't repeat the 3, you don't repeat the 7. Because those are the same numbers. Okay, so this is unioning. That's putting them together. So whatever's in group A and group B, they're together. But these are the same numbers. 3 and 3 are the same, 7 and 7 are the same. Okay? Unless they tell you it's a different number. Okay, that's improbability. That's when you learn it's different. Any questions so far in terms of those notations? Pretty good? Okay. Now, the next notation that you're going to learn to use is the backslash. Anyone know what the backslash is? Not divide. Forward slash is normally divide. What's backslash? Not including. So I want you to write that down. Write that in your notes. Backslash here means except. Except or not including.
A, not including B.
Okay, so in this case here, is I want the list from A, except I don't want anything that is part of B. Okay, so this means except. So if you read it, it just means in list A, I've got 1, 2, 3, 7. I want this number, these numbers, except anything that has B in it. Okay, or has a list of B. Now in the list of B, I've got 3, 4, 5, 6, 7. So out of the list of A, what is part of B?
1, 2. 3, 7.
Yeah, 3 and 7 is part of B, and I don't want that, because that's what they said. They said except for anything that is part of B.
Yes,
So, it's 1 and 2. So the answer for A excluding B, that's what it means. Okay, A excluding B is equal to, using braces, so curly brackets, and you list it out and you say it's 1 and 2, because we don't want anything that is part of B. Now if you do it the other way around, B excluding A would have to then be? What's B excluding A? B excluding A. What would my answer be in this case? What's in B where I don't want to have A?
4, 5, 6.
Yeah. Brian, if I have to call out your name again, I'm going to move you outside. Is that pretty cool? Do you still complain? Alright, you've got 3, 4, 5, 6, 7. Now 3, 4, 5, 6, 7, out of that list, I don't want any groups of A in there. And what we can see is A has 1, 2, 3, and 7. And that again says that 3 and 7 can't be there, so we know the answer has to be 4, 5, and 6. Okay? So here we go, we've got 4, 5, and 6. So the notations that you've learned so far, you learned braces. You only use that when you're listing. Sets, capital letters. Yeah, they don't use little decapitalized letters. What's that called? Uncapitalized letters. Lowercase letters? Okay. So lowercase letters, uppercase letters, yeah? Uppercase letters are only for the sets. We don't use lowercase letters. And intersection union, so those are 3 things so far. Braces, your fourth, and finally, exclusion. Okay, so the symbol for excluding. The 4 things you got: sets, intersection, union, braces, for listing, and excluding. Braces. Union. Intersection. Listing. Listing. For listing things. For listing. Yeah. Okay. All right, now,
Thank you very much. Appreciate it.
let's go with some extra set notation. So you've learned a few there. You just learned 4. Now these are the symbols where you need to understand what they mean. So we go, Will, need you to focus. Otherwise you guys are going to have to separate too. Wherever Ryan's sitting. All right, here we go. N. We've got N, Z, Q, and R. No, you don't have to draw it. It's just what you might see in your textbooks. Normally, when you write it in your exercise books, you can just write N, Z, Q, and R. I'm just doing it so in case you look at the textbook, you go, oh, it looks so different, sir. I'm like, well, this is what it looks like, okay? Here we go, N. N stands for, and I want you to copy this down, in grade 6, primary school, 1 all the way to grade 6, you learn N, which is called the natural numbers. We call it natural because that's what you naturally learn first. You count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 1,000. They're only whole numbers, and they're positive. That's what you learn in grade 1 to 6. Then after grade 1 and 6, you get into year 7, the next type of numbers you learn is that it might not be just positive numbers, you still have whole numbers, but they are also negative numbers. That's one that where you call integers. Integers now exactly the same. So this is grade 1 to 6 primary school. Year 7, you learn some negative numbers. That's the first time you learned, negative 2 times negative 2, or 3 minus 4, and you're like, oh, negative numbers, and you're working with that. Year 7 was the time when negative numbers was tricky, right? And it's trying to remember to double negatives make it positive. That's integers. It's whole numbers, they're both positive and negative. That's what integers are. And we use the letter Z or Z to denote that. After you learnt integers in year 7, you also learnt what we called rational numbers, okay? Now rational numbers are numbers that are whole numbers, except you can express them as a fraction. Now right here, they're fraction numbers A over B, where A and B are integers, meaning that they both have positive and negative numbers there. So an example would be 3. 3 is called a rational number because you can write 3 as a fraction as 3 over 1. Both of them are integers. You can write 1/3. So that's not a whole number, so it's not Z, not N, but it does have a positive number 1 and a positive number 3. So if you can write a fraction where it's both positive and whole numbers both top and bottom, that's called a rational number. Okay, so if I draw a circle just for you to see, when you're in primary school, you learnt 1, 2, 3, 4. After that, any numbers that were new were like -1, -2, -3. That was called Z. Then after that, which is what we generally don't like, fractions, we couldn't just stick with whole numbers. We all like whole numbers, but we had to learn fractions. And fractions came in where you had 1/3, 1/4, 1/5, half. Everyone loves halves, right? These are numbers that we can work with, or any fractions. Not everyone loves it. So Q represents that because it doesn't have, these are new numbers, and you can include whole numbers as well. So you can include 3, because 3 can still be part of it. 3 can be expressed as 3 over 1. Now, listening? Quiet down. Then what did you learn after your fractions, which is in year 10? See, after fractions, there are numbers where you can write it as a fraction, but you can't write it. You can't write it where the numerator and denominator is whole numbers. An example would be, so outside of this, you have numbers like √2. You can't write √2 as a fraction. You can write 2 as a fraction, but you can't write √2 as a fraction. You can have pi. Pi is infinitely, or technically finite, but infinitely you can't write that as a fraction. You have to approximate it. You can't do, let's say, any decimals that are not recurring. So 1.2312417 and doesn't have a pattern, and it goes on. You can't write that as a fraction. So these are called irrational numbers. Okay, so how does that all fit? We call that, yeah, but then it's not a whole number. So we want A and B with both numbers. Okay. Yeah. So now, listening? Right down. So if you think about the bigger circle, R represents any number you can think of. R can have N, R can have Z, R can have Q, and R can have anything that's not Q. Okay, so that's what rational is. Rational are numbers that you can express as a fraction. And then anything that you can't express as a fraction, where the both top and bottom are integers, like surds. That's in year 10, you learnt surds, and a lot of students don't like these two categories. Fractions and surds, since year 10, have always been the most difficult. But the most easy ones, primary. You spent 6 years learning natural numbers. You spent like 1 or 2 years learning year 7 and 8 integers, so you get better at that. And those who don't practice normally find this section hard. So by the time they get to Q, a lot of students in year 10 find it difficult with surds and indices. Indices, surds, and rational numbers have always been the most difficult. So then you get to year 11 and 12, this was the expectation. That you should know the list of these numbers, that you can work with surds, you can work with indices, you can work with fractions, you can work with positive and negative numbers. But what I can guarantee is that everyone in year 11 can do N. Not everyone can do Z, and not everyone definitely cannot do Q, and then by the time you get to surds, you get Q. Yeah? That's what I mean by, that's the basics of what you've been learning, is the list of numbers you're working with. Yeah? Now, what I want you to copy on the side are these examples here. So when they ask you R, most of the time you're only using R. But I just want you to understand that R just means any number you can think of. Okay, any number that you're familiar with now is falling under the category of R.
Anything not for the category of R?
Yeah, that's in specialists, you learn complex numbers. You see. But we don't do that in methods. When you can square root -1, because at the moment we can't do it. But when you go into special, you can learn techniques when you can do it. Yeah.
But also, is there a reason why like rational numbers stand for Q stands?
No, I have no idea. That one I have no idea. There's probably a reason, I just don't know why. Yeah. Okay, here we go. So this is just a better picture of what I just described. But hopefully you understand R just means everything that you've learnt so far from primary school to now. Okay? Now, just 2 more notations I want you to copy down. These are the 2 that a lot of year 11s and 12s get wrong when they're stating their domains. R with a plus on the top, R with a negative. Now R means any number you can think of. So when you put a plus on it, what does that mean? All positive. Now most students will know it's all positive. The one thing that most students forget is that not only it's all positive, it doesn't include 0. Okay, so that's the thing you have to remember. R plus is all positive numbers that you can think of except 0. So it doesn't include 0. And it's the same with R negative. R negative is all negative numbers that you can think of except 0. Okay? So if you want to include 0, how do you do that?
0.
You can't just put a 0 there. So if I just said, this thing has all negative numbers, union. See, union means include. So I'm using the language now. I'm saying, I have all negative numbers, but I also want the 0. So you say union, it's include, take, but you have to list it. You can't just say union 0. So what do I have to do?
What does the hashtag mean?
Numbers. Curly brackets. What this means here is I've just said I want all negative numbers that you can think of, but also make sure you have the 0, because I'm listing out what I want. Okay, so I want the 0. And that's the language that we're using. So that's why I'm saying Chapter 5 is learning how to use the language, Exercise 5A.
That means R including 0.
It's like on the bottom, you can't read it.
Okay, this one just means all positive numbers except 0. Yeah, same thing with this one. All negative numbers except 0. Yeah, R plus R negative except 0.
And that means all negative numbers including 0.
Yes.
Wait, is 0 a plus for a negative number?
It's not part of it. That's why when you write R plus R negative, it doesn't include it. That's why if you want to include it, you have to put a union. Which one? What does R negative mean? All negative numbers, what's this mean? What does union mean? You group it with. So take all negative numbers, group it with. What does that mean? No, I have 0 in it. See, this one says I include 0. This one means have 0. That's all it means. All negative numbers have 0. That's all it means. Yeah? Alright. Now, let's work. Here we go. Let's do some examples. So now you can use the languages. Here we go. Set notation. This is what you're used to seeing. Now I'm going to break up this definition so we understand. So what was braces meaning again? What does braces do? Listing. Listing a set. X colon. Now some of you may know it, or some of you might guess it. What does X colon potentially mean? If we said set, I've got a group of. Now what does this mean? What do you think it might mean? I've got a set of.
What does it mean? X such that, or something like that.
Almost. It is X something. I've got a group of. That's it. I've got a group of X numbers. That's all it means. It just means, so you can put anything here. You could say, I've got a group of coordinates. So how do you do that? You do group of XY coordinates. And you can do that. You can do a group of, I don't know, you could do XYZ.
Can you like do numbers?
Yeah. You can call it whatever. So back in year 7, they used this in your textbooks. They might have said a group of tables. So name tables. I don't know. You could have like a four-legged table, three-legged table, half-legged table. No, it's a colon. It's a colon. A colon's just like this is the group. Okay. All right, listening. Quiet down. So what this really just means is all my X values. So this set has all X values. All X values. This means set. So this is my group. I've got a group of X values. It's all it's saying. I've got a group of X values. Now you're going to read this one. See, this is X. What does the symbol mean again?
Less than.
Oh, it is less than, but X is currently greater than 0, but. So that means what I'm saying is I've got a group of numbers on a number line. I've got a group of numbers from 0 to 1, but you see, it doesn't say including. It says bigger than 0. It says bigger than 0, and it doesn't include 0. So in this case here, I'm saying I want all numbers. Every number that you can think of between 0 and 1, I will have, except for 0 and 1. That's what this means. Okay, so this means I don't have a 0 and I don't have a 1, but I have anything in between it. Okay, and so that's my group. This is my group. This is my group of X. No, this is just a language. Okay? So, how do you describe this? Now, this is the first time we're going to teach you interval notation, and you're going to learn how to use it. So, quiet down. You learned set notation since year 7. What we're not so familiar with is interval notation, but you learned open brackets and close brackets. Open brackets means you don't include it. Okay? Close brackets means you do include it. In this case here, the reason why we call it interval notation is because you're working an interval. You're going from 0 to 1. Numbers between 0 and 1, you can have 0.5, you can have 0.33, you can have 0.011111. You can have all kinds of numbers between 0 and 1. So this just means from 0, the smallest number, to the largest number, don't include 0, don't include 1. Okay, so if I were to draw on a number line, you would use 0, open circle, to 1, open circle, we don't include it. 0 to 1. Does that feel a bit more?
Yeah.
Yeah? Now I'm going to do the next question, okay, because I'm getting you to use interval notation and set notations. Here we go. Let's read this one now. Yasmin. Thank you. Thank you. If we're reading this second question here, we've got set X again, so I've got a group of X's, so this means group of X values that are, now what does this mean?
Less than or equal to.
It means I can have a 0 and I can have a 1, so how would I use my interval notation? I'd use close brackets to say I have 0, I have 1, so it's between 0 and 1. That's much easier to write than doing the left-hand side. Yeah, so interval notation is much easier to do. Now, in terms of the number line, Trent, how do you include it? You would put close circle between 0 to 1, and you draw a full line because it could have numbers anywhere between 0 and 1, but you include 0 and 1. See the difference between the first one and the second one?
Oh, yeah.
First one you don't include. Second one you do. Let's do a third one. How do you do this for interval notation now?
So it'd be 0 would not be colored, and 1 would.
Very good. Yes. So when you're doing interval notation now, you don't include the 0, so you use an open bracket. You don't include 0, but you do include 1 because it says I can have 1 as well. I can be x can be equal to or less than 1. So it can equal 1, so I've got a square bracket. So just like Ryan said before, if you were to sketch this, it would be from 0 to 1. The difference is this is open circle at 0, but you do include at 1. So it's a closed circle. Does that make sense so far?
Yeah.
Feels a bit easy? Yeah, because the main thing I want you to learn is really just this. So I've been spending some time to describe each of these letters just so that you understand that, because that's what you're using for exercise 5A. Okay, you have to be able to do this to make it easier than writing that. So this one's lengthy. We don't like that. You have to be able to read it. This is how you answer it. Okay. We'll talk about this for exercise 5B in a second. Okay. Let's try the last question. What does this mean now? I've got a set, all x values. So I've got a group of x values that are, what's this mean?
Everything.
The x is the numbers I want. What does this mean?
Less than.
Less than, but 0 is less than. So that means x has to be that way, bigger. And so x is bigger than 0. So when we're reading this, x is bigger than 0 or x is greater than 0. So if you think about a number line it would be from 0, we don't include 0, and it goes all the way to infinity. We use an arrow to show that it goes on and on. Okay, so we use an arrow to say it's going on and on. The question is, how do you write your interval notation? Anyone know? So unlike the ones before, you had 0 to 1. This one will be 0 to infinity. The only thing that you got to know, when you write infinity, we never use close brackets because we don't know what infinity is. We don't know what that number is, so we use an open bracket. No, we don't. Okay, it's just the concept. It's a concept that it's an open circuit. I don't know.
In grade 2, we had some maths debate. No, grade 1 was we had some maths debate. No, it's gone. I feel like, yeah, it is. It was like, I can do it. That's how you write it.
Yes, but that's only, yeah, it's true. It's true, but normally when they ask you, like, where find x between this, then you would say it is between, and you do bracket 0 and 1. Yeah. So in exercise 5B, for example, you'll be talking about domain and range. You would write on the side, you would say domain equals 0 and 1. Technically, a better way of writing it, which I haven't taught you guys yet, is x element of 0 to 1. And that just means x is a part of this interval. X is part of this. And x, yeah. Yep. Yep. It looks like this. Yep. It's called a universal set. So it means everything in this box. Everything. And we're going to learn that for the next chapter. Yeah. And that's why I'm trying to teach the language now. You get to probability should be easier. Okay? All right. How do we feel with that? Does that feel all right? Because you're going to do these ones now. I'm going to get you to do that, and I'm going to get you to practice exercise 5A. So let's start. Write down. Copy this down for me. I'm going to get you to figure out A,
Negative infinity.
so on the left-hand side. So you got 0, positive infinity, negative infinity. Yeah, so you're going all the way to the negative side. Yeah. So you think about a number line, you can go all positive or you can go all negative. True?
Yeah. Is the universe infinite? Yep.
In this case, in the number, yeah. In the number sense, yes.
No, like in the actual universe sense.
Oh, that I don't know.
I know it's expanding, but if it's expanding, it has to have some boundary, you know? Because it's like, you start off by that, now it's expanding. You know, technically, hypothetically, you go straight into it, go outside of it. Nobody knows.
Nobody knows.
There we go.
Right.
All right. The 11's listening. Write down. Thank you. All right, here we go. For each and every one of these, I want you to sketch what they're trying to say there. So you got A. Listening. You got A. Bracket -2, 3. What does this mean? Can I please have Sydney? What does A describe here?
Close brackets of 0 to 3.
Not 0?
-2, sorry.
-2 to 3. So -2 to 3, that's the interval. Now, what kind of circle do I use?
Does it include them?
Does it include them?
Yes, because it's closed brackets.
Good. So it includes, so we use closed circles. That is A, from -2 to 3. Let's try the next one. What about B? Can I please have Anne? Fantastic. Whoops. Okay, so we got open circle on -3, closed circle on 4. Will, let's try C.
Why do you mean this one?
Because you were talking and smiling, so I'm assuming you know this stuff now.
Infinity on a number line.
So it's negative infinite hours. Yeah. Open circle. Line. 5 close.
5 closed circle, and so negative infinity, open circle.
Wait, is that correct?
Yeah.
That is incorrect. How did I do it on the last slide? So if you're watching on the last slide, when I had 0 to infinity, how did I do it? An arrow. So you just keep draw an arrow to say that you keep going that direction. So in this case here, instead of having open circle here, you would do that without labeling it. Because that would mean I'll keep going from 5 all the way down. I was asking you to see if you were paying attention. So now you.
I got the first one.
Now you would. Now you would. Okay, E.
Give me the next one.
Did you want to have a go at E again?
Where's D?
E. I skipped D because D is too easy now.
Sure.
Oh, you want to try, Ryan? All right, let's do E. Ryan.
So it'd be -3, and it would be an open circle.
Good.
And then it would have a long line and an arrow pointing that way.
Which way?
Right.
Very good. Excellent. Was that easy? So that's just saying from -3, I want numbers that are larger than -3 in that direction. So that's larger, that's smaller, that's negative, that's positive. It's like this one. That means negative infinity up to 5. So it's 5, everything less than. This is -3 to positive infinity. So -3 all the way to positive infinity. Any number in that direction. Okay, so bigger than -3. All right, fantastic. Now these are the tricky ones. I want you to read them individually. Let's try. Let's jump to D so they can have some time to do exercise 5A. Here we go. Let's try D. Okay, I want you to try D. There are 2 parts of it, and they want you to sketch it on the same number line or represent them on a number line. So here we go. -2 to 3. You guys know how to do that one. I'll do that one for you. But I'm more interested in the second one. So -2 to 3 means include -2, include 3. That's the first part. What's the second one describing? How would I draw that one?
Real numbers between -2 and 3.
So the register.
So what's real numbers again?
Every number.
Every number on the number line. So all these numbers on the number line. What's this mean?
Oh, not include register.
Not including. So I don't want every number on this number line. I don't want.
So it's just -1.
See, explain like.
There you go. So exactly that. You don't want -2. You don't want -3. But you want every other number.
Close brackets.
Open brackets because here you said
I mean, like the circle.
it's open because you said exclude the -2. You say I don't want the -2. So no -2s. I don't want the negative on the 3.
No, but they'd be coloured in. They'd be coloured in, wouldn't they?
No.
But it's closed back.
No, because I know it's closed, but remember you're saying take away the -2. If this was an open bracket, it's like a double negative.
That hurt your hand.
It's like a double negative.
Does that hurt your hand? Is that all the boxing that you do? It's just going to you up?
So when can you get back into it?
Probably the first 2 numbers.
So when can you get back into it?
Sorry?
When can you get back into boxing?
Sparring?
Yeah.
Sparring.
I don't know.
I'm coming to your sparring.
Yeah, come. I would totally. I've actually been asking students back last year when I was sparring.
Which gym? In the city or?